So as we begin today, I wanted to just look at the Google Classroom here with you guys because a couple of things went live today. Number one, down here is today's mini lesson, which spans 6.4, 7.4, and it's about adding and subtracting mixed numbers. And we touched on that a little bit last week on Friday. But we didn't have any homework with the skill. We're just going to continue to build our understanding of it and do some more examples today. And then the next thing that is here is a study guide in prep for Thursday's quiz. So the three main topics on Thursday's quiz are adding fractions, subtracting fractions, and then, I guess I said before, adding and subtracting mixed numbers. So all of those skills are interrelated and connected. So I think if you understand the core content of this these chapters, then you're going to do just fine on this quiz coming here Thursday. And then lastly, as we do each week, we have 20 Freckle minutes that are due at Friday at 3 p.m. So log in to the adaptive math section at your convenience. So if I open the study guide post here, you can see that I have a couple of sections listed, and that's because I took screenshots of problems that were from your textbook, and so they don't have a predictable number order because I grabbed a little bit from each section, okay? So this first section about adding fractions, our game plan's the same. Get your common denominators in whichever way that you choose, whether you use the least common denominator or the easiest common denominator. Add up those numerators, reduce the fraction if you can. And we'll work a little bit on that today as well. Section B, same routine. Instead of adding, you're subtracting the fractions. And then section C is really focused around 6.4, 7.4, what we were working on last week of what do we do when we have a mixed number situation. You can convert just the fractions into common denominators and deal with them, or you can do the around the world trick and deal with improper fractions as you try to add or subtract them, okay? So remember converting from a mixed number into an improper fraction, we had this technique of around the world. You're gonna make it mad by multiplying and then adding up that numerator, keeping the same denominator, and then vice versa. If you were converting it back into mixed number form, you simply divide, right? That top number is your dividend, the bottom number is your divisor. You set it up like a long division problem and you go with it, right? So we're going to continue to practice with the mixed number skill. And how about we work on the problems that are from your study guide, and then for homework, you can go do the ones that are assigned in the Google Classroom that's connected with these workbook pages, okay? So obviously there's not enough space on the study guide for you to smush in your writing. So these would all need to be done on loose leaf, please. And just label the section that we're going to work on right now as section C. And then we will label them with these particular numbers. Okay, Esther.
So we're doing section C.
Yeah, we're going to work on as many as we can with section C right now. And that will help us really practice all of it, because if you can do section C, the rest is a breeze. Okay? Everyone have a piece of paper? Something to write on? You got your multiplication charts, maybe divisibility rules. Those are things that are really helpful when working with unlike fractions. And I'm going to just write on this particular page. All right? And that way we can see the problem set right in front of us while I'm writing, okay? So I'm going to work on this problem first, okay? So I'm going to transfer it down. 7 2/3 minus 1/3. Some people like to set them up vertically, like you could set it up directly underneath it, and that's fine for me. What would the group here prefer today? Do we prefer, show me with your hand, a horizontal arrangement or a vertical arrangement? Just let's see, what do you prefer? So Esther said horizontal, Levi said horizontal. What do you feel like, Tegan? Does it matter to you? Okay. It looks like most people are saying that they like this approach better, so I think that's the method we're going to roll with today. But if vertical alignment makes more sense to you organizationally, then you just write your expression that way when you copy it to the paper. So when we look at this problem here, we have to first decide what to do with our fractions, right? So we're looking at our denominators, and lucky us, what's going on here? They're already the same, right? So we already have common denominators. That's nice. Now there's less calculations to do, less reorganizing to do, because all we have to do right now is simply subtract. Whole numbers minus whole numbers, fractions minus fractions. So 7 minus, what's the other whole number here? There's nothing listed, so can I assume that's a 0? So 0 and 1/3, right? What would 7 minus 0 be? Just 7. And then I go and subtract the numerators, right? And keep the same denominator. 2 minus 1 is 1. Keep that denominator of 3. So 7 and 1/3 is the answer here for 27. That one was pretty painless, wasn't it? Okay, 28. I'm going to be working now on 28. I have 9 4/5 minus 7 1/2. And I'd like you to call attention to your denominators here, because that's the critical part on, am I ready to add or subtract? And the answer here is no, because I do not have common denominators, right? So now you're starting to think, how could I convert 9 4/5 and 7 1/2 to have common denominators? So start thinking of your multiples of 5, start thinking of your multiples of 2, and where does it meet? Esther?
10.
10, yeah, 10 is the first time they meet, but do they meet again at a different factor? Yeah, 20, 30, 40, they'll meet infinitely, right? At those multiples, but we're gonna use the lowest one. So we copy down the whole number, we get the new denominator loaded up, copy down the whole number, get the new denominator loaded up, and then I have to convert them. I have to make the equivalent fractions work, right? So how did I get from a 5 to a 10? What factor made it happen? A factor of 2. So I applied that same factor to this numerator, right? 4 times 2, 8. And then how about the second one? How about this guy? Oops, get back here. How do I get from 2 to 10? What factor do I need there?
5.
A 5, right? So I'm going to use that same factor of 5 to manipulate this numerator. So he has that same value that it was as 1/2. 5/10 is equivalent to 1/2, right? So now they are ready to roll here. We're going to subtract the numerators. We're going to subtract the whole numbers, right? So let's do the whole numbers here first. 9 minus 7 is 2. And then 8/10 minus 5/10 is 3/10. And I'm looking at 3/10, and I know 3 and a 10 have no factors in common, and therefore they can't be reduced any further, right? So this is the simplest version of our answer here. Now, don't erase yet. I want to show you how some people like to do this technique first, and they do 45 plus 4, that's 49 fifths, minus 15 seconds. And they do the same technique, but they use the improper fractions instead of the mixed number when they are getting them ready to subtract. Now, this is a really a big number to deal with, right? So I understand if you do not want to use a large numerator like that, but if you did like this approach, you're totally able to use this. I think it's going to be 75, right? That's 2 plus 5, sure. So then the difference between the two would be 23 tenths, right? So 23 tenths, now we can convert this into a mixed number. How many times, right? We do the division part. How many times does 10 go into 23? 2 whole times, right? And how many leftovers? 3 tenths, just like we got when we did the problem traditionally, okay? So whether you like to keep them as mixed numbers or if you like to convert them into improper fractions, the process is the same. Common denominators, simplify and reduce where needed. This approach definitely takes a little bit more calculation work, but it can be done because sometimes you run into a situation where you're going to have regrouping involved, and that's not so much a problem in 5th grade, but just know that it's coming here down the road. All right, let's take a look at number 29 together. That's 4 1/3 minus 2 3/4. So keep them as mixed numbers, guys. Yeah, okay. So let me call out those denominators, get my mind set on what multiples I'm working through. Okay, 3s and 4s. Where do the 3s and 4s meet first? 3s and 4s. They meet first at 12? Yeah, so I'm gonna get my mixed number ready to be in terms of 12 now. Get the second mixed number ready to be in terms of 12. And now I can go find my equivalent fractions by taking a look at what factor helped me get there. 3 times 4 will help me get there for this fraction. So the top one times 4, it's going to be just a 4. Right? And what factor do I need to get the next fraction in shape? Get as uniform on, right? What factor do I need to get from a 4 to a 12? A factor of 3. Okay, so multiply 3 times that numerator. 3 times 3, 9. So now they're dressed for school. They're ready. Now I can subtract whole number from whole number, denominator from denominator. Numerator from numerator on the fraction piece. So 4 minus 2 gets you 2. And then 4 minus 9, uh-oh. Now what? I can't do 4 minus 9. Anyone know how to do 4 minus 9? Uh-oh. We're going to have to do some regrouping. I told you it was coming. Let me relate a similar situation. So when you go to subtract this expression here, you don't have enough value in this 0 to subtract 2 from it, right? So then we've learned this technique called regrouping, where you take a group of 10 from the tens column and convert it to a big pile of 1s, right, in the column next door. And you use that extra value in a column that you need it so that you can perform the subtraction, right? So we're going to do that same technique of regrouping. It just is a touch more difficult when it comes to fractions because it's not always related to powers of 10 like our place value system is. The regrouping value is based on the fraction. that you're working with. So if I were to borrow or regroup this mixed number and take away one whole from the mixed numbers here, I'd be left with just 3, right? Now here's the tricky part, is when I regroup that to the fraction column, I can't just slide a 1 on here because that is what 10 is. We don't want to add 10. We want to add, well, what is the value of a whole in terms of this fraction? This fraction is out of 12s, right? So I have to use 12 as my value that I'm combining with this numerator to represent one whole. So if I'm going to add 12 twelfths to this 4, what would this new numerator be now? 4 plus 12 makes 16, right? So I'm actually going to just rewrite this entire fraction as 3 and 16/12, which we know is equivalent in value to 4 and 4/12. We know they're equivalent in value, but this one's going to help us do the subtraction, right? So I'm going to now have enough value in the numerator to perform the subtraction. Okay, now let's go and do the subtraction now. Whole number minus whole number. So 3 minus 2, that's 1 now. And 16 minus 9, that's 5, nope, 7. It's Monday, forgive me. 7/12. So 1 whole and 7/12 remaining. And this fraction is in reduced form. There's no common factors to pull out between the numerator and denominator, so we're all set. So this regrouping with fractions is a difficult skill, and the more that you practice it, it will get easier, okay? So the way that I know it's going to happen is my estimation sense kicks in. I'm looking at this fraction and I'm saying that, oh, the fraction 1/3 is closer to 0. And the fraction 3/4 though is closer to 1 whole, right? So if I'm removing or trying to take away a bigger amount from a smaller amount, this regrouping situation is going to happen. Preview number 30. Do you think it's going to happen for number 30? So 7/8 is pretty close to 1, right? And 1/4 though is pretty close to 0. So will that regrouping thing happen for this one? Or would I be able to subtract without doing regrouping this time? So you can't do 0 minus 1, right? But you can do 1 minus 0 without regrouping. So this one should be all set and there won't be any regrouping involved. Look at number 31. Will there be regrouping involved? I'm trying to take a fraction that's probably close to 1/2 and subtract, oh, there's no fraction at all. So I will probably be able to do some subtraction without regrouping for this one, okay? Let's work on a couple of addition problems, and I'm going to show you how regrouping sometimes is necessary in addition, but not until after you get a final answer, and your mixed number might have a whole number but then an improper fraction with it that will regroup and make that mixed number in proper standard form. So let's hit number 39 right now, okay? 6 and 3/8 plus 2 and 1/8. And whenever I see a team here that has the same common denominators, I know that I kind of got a freebie here, right? I don't have to put them in terms of each other. They already are. They're already dressed for school. So now I just have to combine whole numbers with whole numbers, fractions with fractions, right? 6 plus 2, 8. 3/8 plus 1/8 is 4/8. And now I just step back and I say, well, can I reduce that at all? Can I recognize a common factor that those two numbers share and divide it away. Do 4 and 8 share a common factor? Yeah, Michael, do they?
Yes, they can both divide by 2.
Sure, they can divide by 2. Anything bigger? Look at, they can divide by 2 again, right? So this is a lot of dividing, isn't it? Could I have taken this mixed number and divided it by 4 right away instead of 2 and got to my answer a little bit faster? You can. Or you can do this divide by 2, and really you're doing the same technique. You're just doing it spread out over 2 different calculations. Okay, but you still get 8 and 1/2, no matter which way you go about simplifying it, by a factor of 2 and then 2 again, or a factor of 4. Are you able to copy down what I'm writing? Am I going too fast? How are you guys feeling?
Good.
Okay, good. Good. All right, number 40. What are you noticing about 40? Woohoo, right? So what's that mean? What do we do first? Come on, what do we do first? Your turn now here. Take over. Take over. Your turn to teach me. Esther, what do you think? What do we do first?
Find a common multiple.
A common denominator. And do they have it?
Yes.
They already do. So now what do I do? Well, I've got 2 numbers and I want to combine them, right? So how do I go about combining mixed numbers? I just add up all the numbers together? Is there a certain type of number that belongs with a certain type of number? Like, give me some direction here. Anybody else? You guys are worrying me a little bit here. So if you're not sure what to do on this type of problem right here, making me a little worried. But check this out. We've got a whole number, right? And a whole number. Should we combine the whole numbers? Yes, let's combine the whole numbers. What would 12 plus 5 be?
17.
17, thank you. And then we have to deal with the fractions now, right? What would 3/10 and 7/10 be?
10/10.
10/10. So this is the situation I was telling you guys about. This is regrouping, but this time, instead of regrouping in order to subtract, we're going to regroup in order to give a nice simplified base answer. So if you look at 10/10, you should be thinking, hey, that's equal to 1, right? So then, therefore, I should add that whole number 1 to the place where the whole numbers go, right? So what would 17 plus 1 more be? 18, right? So this is the final simplified answer of this problem, is 18.
Miss Moore, I have a question about that.
Sure.
Does it have to be 10 out of 10, or can it be like a different fraction that has all of
A
it?
complete set. Anything that has a complete set. Like when we were working up here with 12ths, if you had 12 12ths, that would be equal to 1. If your denominator, let's see, for this one would be 6. So if you had 6 6ths, that would be equal to 1. So as long as you have, that's the tricky part about regrouping with fractions, is it's the way that it looks is going to be dependent on what denominator is at play here.
Okay.
Okay, as long as it's a complete set, 10 out of 10. Okay, 41. 1 and 1/2 plus 4 and 1/6. And I can tell right now there's going to be no regrouping at the end, because if I use my estimation sense and say this is half, and this is way smaller than a half. So a half and a little bit more is not going to spill over the top of one whole, right? So I won't have that regrouping problem here, but I do need to find what Esther told me, a common multiple between these two numbers, and it's going to be 6. So let's get the uniform set out and let's convert the fractions. How would I get from a factor of 2 to a factor of 6 for the first one? Factor of 3, right? So multiply times 3 for this numerator as well. And then for the next fraction, 6 to 6, hey, it's all set up already. I don't need to multiply at all for this next one. He already was in terms of 6. So now I've got, I'm going to add up my whole numbers with my whole numbers and my fractions with my fractions. 1 plus 4 is 5. 3 6 plus 1 6 is 4 6. Can that be reduced at all? 4 over 6? Yeah, by 2, right? So I can show it. Divide by 2, divide by 2. The whole number stays the same. Don't forget to transfer that guy over. And then you find out that the reduced form is 5 2/3. All right. I want you looking ahead at 42 and 43. At 42 or 43, which one do you think is going to need regrouping at the end? Meaning you're going to get fractions that when they come together are going to make a quantity bigger than 1. Can you tell which one? 42 or 43? Which one is going to spill over? Use your estimation sense and look at the fractions. And
42? Maybe, I don't know.
make a judgment based on what's close to 0, half, or whole. Remember we did that at the beginning of fraction study, 0, half, or whole. So 3/4 is like halfway between half and whole. So this one is pretty close. Well, it's actually dead center between half and whole. But this one is very close to 0, right? This guy is over a half. He's bigger than 1/2, right? And this one is between a half and a whole. So he's way bigger than 1/2. So if you have 2 that are bigger than 1/2, what's going to happen? You're going to have more than a whole at the end, right? Because if you have only space in your denominator for 2 halves and you have more than that, you're going to end up having to regroup. So how about we do 43 together? And then I'll let you finish. I know you had 30, 31, 42 left to do on your own on this part of the study guide, but 6 5/8 plus 2 3/4. All right. Action plan, always get common denominator first. Between 8 and 4, what's going to be the easiest denominator to use? Between 8 and 4, help me out. What's the easiest denominator to use?
8.
8. Okay, so I copy down my mixed number with the denominator I'm going to be using. Take a look at the first fraction. Hey, he's already in terms of 8, so I just transfer that numerator over. And on this fraction, I'm going to have to use the factor of 2 to get there, right? So 3 times 2, that's 6. See, I knew it was going to happen. I'm left with 8 11/8. So that's bigger than 1 whole, right? I can't leave it like that. I can't leave it as 8 11/8 because that's an improper fraction. So I'm going to go and convert this guy. How can I pull apart 11/8 into 1 whole and then the extras, right? How many eighths would make 1 whole? How many eighths would make 1 whole? So here's the improper fraction. I'm going to kind of break them up into two parts. I want one part to represent one whole so that I can combine it with the 8 next door, right? One way that people like to do this is they just do the division. So they'll do 11 divided by 8, and they'll say, how many times does 8 fit into 11? One whole. And how many leftovers? 3, right? So then the remaining fraction would be 3/8. So instead of writing 8 and 11/8, here, let me get this arranged for you. It's hard to fit all this in this little screen, guys. They would say, instead of 11/8, I'm going to use the new fraction 1 3/8. So what would that be together? 8 plus 1 3/8. It would be 9 3/8, right? So I have whole numbers and I have that extra fraction piece. Now, is 8 and 11/8 equivalent to 9 3/8? It is. But this format of the number where your fraction involved is proper and it has the lowest terms possible, that's the format that mathematicians have agreed upon would give your final answer in simplest form. If I went and checked the value of this, do you think I would find that it's equivalent to the value of this one? It would be, because why? They're equivalent. They're equal in value. 8 times 9 is 72, plus 3, 73, 74, 75/8. 75/8, remember that, 75/8. And then this one, 8 times 8 plus 11, hey, 64 plus 11, 75/8, right? So they're equal. I've just checked myself to make sure I did my regrouping the right way. But if I were looking for a final answer on this type of problem, this is the one I would expect, right? Because I've regrouped, I've simplified, and it represents the sum of these two mixed numbers. Okay? So for your assignment today, it's related to this. You can see it on the Google Classroom post from today. And let me pull up the instructions here for you. 98, workbook 98, 1 through 12. And if you could please take a clear picture of your work. And if you do it on loose leaf, if you need to stretch it out, space it out, that's fine by me. And then you will not have math class tomorrow. So you have a couple days here to work on this workbook page, 98, 1 through 12. I'll start to pick away at that study guide. When I see you for class on Wednesday, I'm going to go through any unresolved problems from that study guide. So we did a lot in the hardest section together today. We did a lot of the hardest ones. But I might pull some similar problems out when we meet on Wednesday, so that we can continue practicing the hardest skills together, like the regrouping and the what to do with a mixed number that has an improper fraction at the end, those kinds of skills. But as far as the adding and subtracting the fractions part, section A and B, I think those parts you're really great at independently at this point. Then Thursday, we'll take our quiz. And then Friday, I have some fraction games planned for us. Now, let me just say it, because I have been hearing grumblings of a possible weather event going on here in the next 12 hours, if you get my drift. But I'm not sure how that will affect the rest of your classes tomorrow, if in fact we do not have school for a snow day. I'm not sure yet. So I would stay tuned to any announcements from the school as far as what procedures we would follow if that happened. They might have us Zoom, they might not. So stay tuned, and that's all the information I have for you right now. What's the technique for a snow day? What do you sleep with your pajamas inside out, spoon under your pillow? What are all the good tricks?
I think some people put an ice cube down the toilet.
An ice cube down the and there was something on the windowsill. What do you have to put on?
A white crayon.
Well, you guys better get busy. Okay. Well, thank you for coming by today. And this lesson has been recorded if you ever need to come back and rewatch some of those more difficult ones about regrouping. Okay. I'll see you guys on Wednesday. All right. Have a great day. See ya.
Bye.
Bye.
Bye.